of liquid, which they did. They were also asked to define some standards for off-the-shelf ladies' clothing, sizes, so that there was some chance you could buy something, take it off the shelf and take it home. There are standards for, the World Health Organization has a standard for chocolate. They define how much cocoa butter, how much fat there must be, and so on. We have standards for music. You couldn't create an orchestra unless we could tune our instruments, so they agree with each other. So we have to agree on what middle C is. There's an ISO standard for that. There are standards for color, so that you can accurately reproduce things. In theory, we have standards for traffic. We agree on what side of the road we will drive on, because if we didn't, there would be complete chaos. In shipping, a very simple idea. Before the invention of the shipping container, when you put stuff into a ship, you had to pack it in very carefully. In fact, I noticed the little plane I came on today, from, where did we come from? Wherever. From Sao Paulo. The way they packed the bags in there was one at a time. So it was the same with early shipping. You'd have irregular spaces down in the hold. You would have to take account of which things need to come off first and how to make the best use of the space and so on. And then somebody came up with this brilliant idea of just having this big metal container, standard size, and you just pack the stuff in that, and then you don't have to unpack it till it gets to its destination, because you take the container and you put that into a ship or onto a train or onto a truck. And think about this. This is packet switching. This is like the internet, but instead of information, what we're packet switching is physical goods. And that's why it still boggles my mind. You know, in the US anyway, they sell this water that comes from Fiji, and we have potatoes that come from New Zealand. And you know, it's still, I don't quite understand how it can be economically feasible to take something bulky like water or potatoes and ship it literally halfway around the world, but we can because of this very simple idea. There's an ISO standard, of course, for the size of these containers. We wouldn't have any sport unless we agreed on the rules of the game, so FIFA defines the rules for football. Don't look too closely at this, but the World Health Organization has a classification of diseases with every possible thing that can go wrong with you is well defined with a number, so that the insurance companies and the doctors can kind of agree on how they're managing. I was in the dentist a few years ago, and there was some, what they call them, a mold. You know, if you can make false teeth, they create this plaster mold, and it was sitting there on the counter, and there was a little written note. It said, please set teeth shade A3. So I had never thought about it before, but there is indeed a standard, which these days is very complicated, using complicated spectral reflectance, spectrophotometers, to actually measure the whiteness or the non-whiteness of people's teeth, so you can match up false teeth with real ones. Barcodes make life easier for shopping, ISO standard there. Specialized form of barcode, ISBN, uniquely defining a book or a piece of music or whatever. Standards for home entertainment, Blu-ray 1 over HD DVD, that's good because Blu-ray has Java in it. Standards for encoding music, MP3, and so on. Here's a couple of examples of what happens when you do standards wrong. In Baltimore in 1904, fire broke out in the downtown business district. It was such a big fire that all the surrounding towns said, oh, we'd like our firefighters to come and help. They brought in their fire engines, they went there, they went to the fire hydrants and discovered that they couldn't hook up their hoses to the fire hydrants because there was no standard for the sizes and the couplings. So 1/3 of the city burned down. It cost $144 million to rebuild it, and that was real money in those days. And guess what? Shortly after that, they said, we probably better standardize the coupling between a fire hose and a hydrant. Here's another example. 1999, this Mars orbiter took, I don't know how long, 9 months, a year to get from Earth to Mars. Was about to land. They fired the booster rockets to take it down, and it went 5 times faster than they expected and crashed into the surface of Mars and was destroyed, because the guys who programmed the hardware and the guys who had written the software did not actually agree on whether they were using metric or imperial units, and so you had a mismatch. The $64,000 question is whether we are artisans, and we, I mean computer programmers. Artisans make stuff by hand, and I talked about, you know, the difference between a blacksmith making a wheel for a cart and machine tooling it. So I used to do woodwork when I was younger. It's great fun. You know, you kind of eye things, you measure them. If they don't fit, you can kind of shave things down and fit them together. And it's a very creative process, but it's slow, and the things you create tend to be one of a kind. Alternatively, you can do things in an engineering manner. You can take standardized parts and you can put them together. If most software people call themselves engineers, I don't think most of them are. Maybe people who work in aerospace are engineers, but most of us are not. Because if we were engineers, bridges don't fall down due to bugs, hardly ever. And yet software programs almost never run first time or second time or third time or fifth time. We just say, oh, it's going to crash, no big deal. We'll just fix it in the next release, we'll debug it into existence. If we were engineers, that's not the way things would work. So we've got a ways to go before we can learn to be real grown-up software engineers. And standards is what helps us to do that. We've done this, we've done this. You get two kinds of standards. Some are called de facto standards. They just kind of emerge out of the marketplace, like Windows, or PDF. Adobe invented PDF. They've since standardized it formally. But originally it was just their invention. It was a very great invention, but it just came out of one particular company. De jure standards are developed as a result of a formal process. I can skip this. Open standards. As with open source, it's important that standards be open and collaborative. So you want a formal process. You want to allow anybody who wants to participate to do so. You want a level playing field so that everybody has the same opportunity to participate. You want transparent governance and processes. How things are done should be well documented and should be visible to everybody. And it should be possible for everybody to implement standards. That's what we mean by open standards, similar to the idea of open source. The essence of standards is that it's possible to have multiple implementations. Without a written specification, that's not possible. Here's an example. Last year, Facebook, a lot of their code is written in PHP, and they decided that the default runtime engine called Zend was not efficient enough for them. It didn't scale. So they figured they could do better, and they decided they'd write their own. So they started looking at this, and then they realized we can't write our own because we don't know what this engine is supposed to do. There is no formal specification for the language. There's just this implementation created by that PHP open source community. But if something behaves in a particular way, we don't know whether that is because that's the way it's supposed to behave, or whether it is a bug, or whether it's something that is up to the implementer. So they said, okay, before we can create our own implementation of this engine, sorry, it's now 2016, so it was the year before last, they said they would start by creating a formal specification for the PHP language. People who build big systems, global systems, like ATM networks that span the world, or Federal Express, global shipping, put things into space, mobile communication networks, airline reservation systems, and so on. These guys want to build stuff on standards because they want to have a choice. They don't want to be locked into buying their stuff from one particular supplier. Vendor lock-in is the term we use in English. And back when I started, 30-some years ago, if you bought a piece of hardware from IBM, that was it. They owned you for life, because the only supplier for other stuff that would work with that hardware was IBM itself. And the only supplier of software that would run on that hardware was IBM. And the only place where you could get people to train you in how to use this stuff or get documentation on it was IBM. So it was completely proprietary, and you were locked in. People don't like that. If you have standards, then it is possible to have more than one implementation of a particular thing, and that means that I, as a user, get to choose who I buy this thing from, and if I buy it from you and decide I don't like your quality or whatever, then I can switch over and I can buy it from you. and the two things will work in the same way in the system that I'm putting together, because we have a formal specification that both of you are adhering to. So, in our world, two kinds of standards that we care about. One is about languages and protocols, how we communicate with machines, or how machines communicate with each other over networks, for example. And the other is interfaces, how pieces of software talk to each other. Remember I said when I started there was no such thing as any of this. There were no libraries of any kind. I had to write my own libraries for input and output and so on. But today you can take a bunch of stuff, almost pull it off the shelf and hook them up together. And because the interfaces are well defined, you can actually hook these pieces together. So now we're beginning to behave more like engineers and less like artisans. In the Java world, our standards are developed collaboratively through the organization that I run, the Java community process. Unlike Windows, with Windows what you get is what Microsoft decides you're going to get. Look at the disaster that Windows 8 was. Microsoft just decided this is what you're going to get. That's not the way Java works. Oracle has a lot of influence because Oracle paid many billions of dollars for Java, and Oracle has many hundreds of engineers working on it. But we do the work collaboratively, and Oracle's competitors such as IBM and HP and Red Hat all collaborate with Oracle in defining the next version of the platforms. We also have representatives from the open source community such as Eclipse and many Java user groups. Don't need to go into the details. The point is that for each of the three platforms, Java SE, Java NE, and Java EE, you have these pieces of technology, and the interfaces between them and around them are defined by formal specifications. So they know how to talk to each other, and so people who implement these know how to create another implementation of Java EE that will behave the same way as the original one. So we have a formal process of creating what we call Java specification request, which is basically a single version of a Java specification. Someone who belongs to the JCP decides that they think it would be a good idea if we defined a new version of an existing technology or codified some new ideas in the form of a new technology. They write a formal proposal, they get a bunch of people together to help them in what we call an expert group, and this group has to deliver three things, not just the specification, but also what we call a reference implementation and a test suite that we call a TCK for reasons I won't go into. Now, the purpose of the reference implementation is it must be a complete implementation of the spec. So this is a way of determining whether the spec is actually realistic, whether it's implementable at all. I could define a spacecraft that is designed and powered by an anti-gravity machine. Well, fine, I can define it, but nobody can implement it because it's not possible. So a real-world implementation of the entire spec is a way of debugging the spec. The test suite is used to test whether implementations conform to the spec. And as you build a test suite, you'll find ambiguities in the specification. As you know, when you write tests against something, you have to have a precise definition of how that thing is supposed to behave, otherwise you can't write a test. And when you run the test against the reference implementation, you may find bugs in your tests or bugs in the